So take another example. Suppose I am having an object whose mass is 10 kg and it is connected with two threads like this. One thread is at 53 degree with the horizontal and second thread is perfectly horizontal like this. So suppose tension is T1 here and tension is T2 here. So we need to find the tension in the two threads. Find tension in strings. So for finding tension in the strings, again we will apply the Lamis theorem. So what are the different forces on this object? So one is mg, one is tension, the string is pulling it rightward, and one is T2 which is pulling it at some angle with the vertical. So if they are in equilibrium, since system is at rest, object at rest means forces are balanced, forces are in equilibrium. If forces are in equilibrium, it means that we can apply Lamis theorem. Applying Lamis theorem, if we apply the Lamis theorem, we can write T1 by, so we need to find some angles. So this angle is 90 and this angle, if we say this is 53 degree, so this total angle will be 53 plus 90, that is 143 degree, and this side, since this is 53, this will be 37, so this total angle will be 90 plus 37, that is 127 degree. So this angle is total 127 degree, 37 plus 90 is 127, and this lower side is 143 degree, because this is 53, so 53 here, 53 here, so 53 plus 90 lower side, so total is 143. So T1 and the angle in front of it, that is 143. So we can write T1 sine 143 degree equal to T2 by, T2 is here, so T2 by, how much is the angle in front of T2? That is 90. This one angle is in front of the T2, so 90. So T2 sine 90 and angle in front of mg, so mg by, so in front of mg this angle, the 127 degree, sine 127 degree. So you can write it like this: T1 by sine 143, T2 by sine 90, and mg by 127. So if you solve it, you can simplify. The sine 143 can be written as sine 37 degree, because 143 is 180 minus 37. So you can write like this: T2 sine 90 is 1, so you can write 1, and mg, so 10 kg into 10, g value is 10 kg into 10, and sine 127 we can write as sine 53. So this way we can write. Now what will be value of T1 and T2? So T2 we can write as 10 into 10 by sine 53. So that is how much? 100 by sine 53 is 4 by 5. So that is 125 Newton. Similarly, for T1 we can write, sine 37 degree by sine 53 degree into 10 into 10. So sine 37 is 3 by 5, sine 53 is 4 by 5 into 100. So that is 3/4 of 100, so 75 Newton. So the forces in the tension in T2 will be 125 Newton and tension in T1 will be 75 Newton. The same thing could also be found by some different method. I am going to discuss one more different method, the more elementary method. Okay, so what we can do is we can write equation along vertical and equation along horizontal. Equation along vertical. So if I write equation along vertical, how are the forces balanced? In vertical direction, you can see there is one force mg and T2. T2 is having a component in upward direction. T2 is having a component in upward direction. You can see T2 is acting like this. The component of T2 is in upward direction. So net force is balanced. So mg will be equal to T2. This angle is 37. So you can write T2 cos 37. mg is downward and T2 cos 37 is in upward direction. So you can write mg equal to T2 cos 37. Similarly, equation along horizontal, you can write equation along horizontal, we can write in horizontal also it is balanced. So one side is T1 and second side is T2 sin 37. So T1 equal to T2 sin 37. So these two equations, if we solve, we are going to get the value of T1 and T2. So if we solve this one, T2 will be mg by cos 37. So mg is 10 into 10 and cos 37 is how much? Cos 37 is 4 by 5. So 125 Newton. And second is, if you use this T2 here, 125 Newton, and sin 37 is how much? 3 by 5. So that will be 75 Newton. So in this way also you can solve. So both the approaches can be used.